okay, iron 3 will actually form back into iron 2 solid. Okay, I didn't have the picture where the transformation, but actually we see that there is a layer of black color suspended materials occur after 3 months. So meaning that iron 3 is transformed into iron 2 solid. So iron 2 solid is actually black in color. Alright, so this will be the acetate. And then after that, at the same time, it releases phosphorus. Okay, so this groundwater actually releases phosphate into the water, and then from here it has ammonia as well. Okay, remember our bioenzyme have phosphorus and ammonia, so it actually drives the formation of algae into the water. So when it drives the formation of algae, it starts to produce oxygen, and initially there is no water striders in the environment, and we see the water striders are actually thriving in the environment. Okay, just too bad that we do not have the pictures to show that. And then after that, of course, the ammonia, because of the bioenzyme added, and because we have ammonia, of course, we will have nitrate at the same time. But then because we have bioenzyme added, then the nitrate will turn into nitrogen. Okay, it will turn into nitrogen by nitrification, and of course the sulfate will increase. So based on this theoretical mechanism, so I try to look into all these parameters to see if it fits well with this theoretical mechanism. Okay, so this is the pond water quality, and the classification is measured using according to water quality index in Malaysia. So of course the pH and in pond 1, pond 2 range between pH 2 and pH 3, and then for dissolved oxygen it is about 3.9 to 5. Okay, and then for total suspended solids, meaning that the suspended material is 15, 5 and 6.7, and then it's categorized as class 1. And then for the chemical oxygen demand and biochemical oxygen demand, it falls under class 2 and class 3 for both ponds. And for ammonia itself, it is fall under class 3. Okay, then of course I measure the alkalinity to see actually how does it affect the changes of pH. Okay, so we take a look on pH and alkalinity first. Okay, so when you look at the pH, the purple line on the top shows the enzyme dosing day. Okay, so we dose like every day to every 2 days. Then we will dose the bioenzyme, and then after that you see that there are spots that actually there are days that we actually didn't dose. Is because we conducted this test during movement control order, meaning that we conducted it during COVID period. Okay, so we conducted it during COVID period. So I really salute with the volunteers and their commitments actually that has been there with me for 6 months. All right, because I think this movement control order was just lifted. So for us to pour continuously, it is quite impossible because there are many people who are involved in this pouring. Okay, then after that, I also tally with the rainfall data, because I think in the previous talk with Indonesia, I think someone actually raised these questions. I think it is from India. They raised this question that, okay, how does it has to look into a seasonal and all this. So I didn't manage to answer that question, but then today I managed to answer it in India platform, where actually I did measure the rainfall. Okay, the daily rainfall. Okay, I teach the volunteers how to see the rainfall, how to measure the rainfall on that day. So we can see that actually when the pH actually is about 6 when you have high rainfall. But then when there's no rainfall, the pH can drop up to about maybe 4 or below 4. Okay? So this means that actually rain would help to increase the pH through the infuse of alkalinity. It's because this is also can be seen over here. So meaning that when you have rain, the alkalinity slightly increases a little bit. But then when there's no rain, the alkalinity actually quite pretty low. Okay, and then the pH actually has a linear correlation with alkalinity. So alkalinity would mean that the infuse, because when you have rainfall, they actually will bring down a little bit carbon dioxide into the water, and then after that it will increase the alkalinity content in the water a little bit, thereby increase the pH a little. All right, and then at the same time, because it's like there is no rain, okay, during the oxidation of iron 2, okay, into iron 3, it will release 8 hydrogen ions, meaning that when it starts to release hydrogen ions, okay, then it will mean that you are decreasing the pH of the water. Then after that, during the reduction process, when you apply bioenzyme, Okay, then at the same time, it can actually release carbonate and one hydrogen ion, meaning that when you release those two carbonate, it can actually help to increase the pH a little bit. Okay, so this is the reduction of iron 3. Okay, all right. So during rainfall, we expect that time I expect that because it's like you have heavy rainfall, you will infuse of oxygen, and then at the same time you will have a lot of iron 2 going into the water. We expect that the total suspended solids will increase, but actually it didn't, where actually bioenzyme has the capability to actually reduce, okay, they have the capability to reduce the total suspended solids content. Okay, so the suspended solids content, actually this is the rainwater, so you can see that the total suspended solids actually is still 0 during the rainfall. Even after over here at about 100 to 130 days, you would still have a lot, you still see 0, okay, 0 total suspended solids during this period of time at rainfall. So it means that bioenzyme has the capability to actually flocculate, okay, the total suspended solids. All right, so this is from pond 1 until from day 0 until day 41. So actually for the natural environment, in order to treat it naturally, time is very important, meaning that you need to have time. It is not that today I dose in, tomorrow I will see a results. I think a lot of people have that, because initially the volunteers, when they dose until the 2nd month, they were telling me that they wanted to give up actually, because they don't see there is any change in the pond water. Okay, so it's like I keep reassuring them that the data actually are good. Okay, the data actually show improving trend, so we need to continue. All right, so this is pond 3. Okay, we have pond 1 and then we have pond 3. So the pond 3, initially we didn't even see there's a piping underground. Okay, then after that we realized that actually they are piping at day 31, and then at day 46 actually that you can see that the water has become much clearer, okay, after 46 days. So meaning that it is nearly 2 months, 1.5 months of dosing, only then you will start to see results. All right, then we look into the chemical oxygen demand and biochemical oxygen demand. Over here, it is not the organic, the COD and BOD is not contributed by organic, but the conversion of iron in the water. Okay, so we can see that even during rainfall, okay, during rainfall actually it will actually they start to decrease. Even with rainfall, you'll see that the COD and BOD actually decreases. Okay, it decreases to the lowest point, but then because it's like we stop dosing. Okay, the moment that we see that there's a stop dosing, you will see the COD start to spike as well as the BOD start to spike. So when you a bit consistently, a little bit dosing, then you will see it to start to bring it down. Okay, so this would mean that dissolved iron 2 contributes to COD and BOD 5. So meaning that if you increase the rainfall, you increase the dissolved oxygen, you increase the formation of solid iron 3. Okay, that is by right. But then when you look at the data of the total iron which we measured over here, okay, it doesn't seem to actually increase or decrease. So this is a question to myself, that bioenzyme really help in reducing COD and BOD. That is a question that I have that time. So theoretically, the COD and BOD should increase. So I did a sample 2 to 3 days after the rain event. Actually, we found that actually even after the rain event, we will see that there's a decrease of COD and BOD even after the rainfall. Okay. So when you have a low total iron at day 41, it is due to the settlement of the iron. So from earlier, our reduction of iron by acidic content in bioenzyme is actually possible because it can reduce the iron 3 into magnetite, okay, which is the black color kind of iron. All right, and then this is what I found in inlet in pond 1, pond 2, and pond 3. Okay, so we have pond 1, this is at the inlet, and then this is pond 1 itself, this is pond 2, and this is pond, this should be pond 3. Yeah, this should be pond 3. Okay, so you can see that actually the initial, okay, the incoming, the iron, okay, the solid iron 2 content is actually only 62%, okay, but then with the dosing of bioenzyme in pond 1, pond 2, and pond 3, you can see that they have actually increased the percentage from 62 to about 79 or 80. Okay, initially you can see that it is about 80%, then when you stop dosing, then it decreases a little bit and then increase. And then you can see that the iron 3 also is start to decrease, meaning that the iron 3 or iron oxide in the water start to decrease, as well as the dissolved iron 2 start to decrease. So this means that actually bioenzyme can actually help to bind the iron 2 together. Alright? I think it works the same for any toxic metals as well, just that for arsenic you have to be very careful, because arsenic 5 into arsenic 3, it might be more potent. So you have to depend on what kind of heavy metals that you are trying to treat. Okay, and then after that we look into the nutrients. So in the nutrients, when we see that there's a dosing of nitrate of bioenzyme, the nitrate start to reduce and increase again. So we see that actually acetate reduces the nitrate, leading to the accumulation of sulfate. Okay, so we can see that the theoretical actually works for this point, works for this iron point. Okay, then after that we have reduction of solid iron 3, and then because it's like we have dissolution of phosphate. Okay, when you reduce iron 3, then you see dissolution of phosphate, and your phosphate will start to increase and decrease at the same time. Alright, and then of course our ammonia level will also reduce, okay, when we dose bioenzyme, but once we didn't dose, then it will start to increase. And then we see actually the water starts to turn a little bit greener, means that there are actually the formation of algae in the water. Okay, and then we have seen some increase a little bit in the dissolved oxygen. Alright, so in a summary, okay, we can see that from day 0 to day 41, our pH actually, it is between 6.1 to 5.8, because in Malaysia, once it falls below 6, it is considered as A3, class 3. Okay, for TSS, it remains at class 1, just that it reduced from 15 to 0.02. For COD and BOD, actually COD and BOD are quite remarkable, where it improved from class 2 to class 1, and then class 3 to class 2. Okay, and then for ammonia, it actually increased or enhanced the quality from class 1 to class 3 to class 1 within 41 days. Alright, and then for this is the same for PON2, meaning that we have actually 3 replicates in, this is the second replicate in PON2. So the PON2 also showed a reduction result, just that for COD it increased a little bit because it is in the middle pond, and this pond is a bit bigger, so it tends to accumulate more iron over here. Okay, just that the ammonia is better. It has improvement in ammonia as well as TSS, or total suspended solids. And then for PON3 actually also showed a very good results, meaning that the pH actually stays the same. Total suspended solids goes into below 0.01, and then for COD and BOD for COD goes into nearly 0, and BOD goes into about 0.9, and ammonia actually returns from 0.77 to 0.28. Okay, so this is at day 8. After we dose the bioenzyme, actually you will see that there's a formation of, all these are actually iron, okay, iron oxidizing bacteria and iron reducing bacteria that is actually forming here. So when you see this, initially we are quite worried, because we thought that does the pond water become the, actually it's not. Actually it's the bacteria. So you just need to have a mixing, meaning that when you are applying bioenzyme into the environment, you need to have a very good mixture, which I think that is why river will be a very good application for bioenzyme, because you have a mixture and it is moving. Because stagnant river or stagnant pond water, you really need to have a mixing so that the bioenzyme can be properly mixed and the bacteria actually can settle down. Okay, so this is at day 41. So you can see that the water actually turned from orange to a more beautiful color water. Okay, then after that, in May, because we start from February, and then after that in May is like in 2021, our application of bioenzyme actually stopped. You can see that actually the water still have a little bit of what is the word that I want to use? A little bit of iron oxidizing bacteria at the top. But then once we stop dosing the bioenzyme for a period of the time that you can see in the graph just now, actually the iron came back. Okay, the iron oxidizing bacteria actually came back. So when it came back, it means that we cannot, if you have a source of pollution, you cannot stop applying bioenzyme. Okay, but of course you will need to do a lab study or lab analysis before you do the pouring, because we do not want to contribute. Because remember, bioenzyme, it contains high content of COD, the ammonia, and the phosphorus. Okay, we have to really measure the water quality first, and then we need to calculate so that it will not increase any of the water quality parameters in the existing water quality parameters. Okay. So the take-home message that I want to bring to everyone is, if pollution continues, bioenzyme needs to be continuously applied, but this does not mean that we can continue to pollute the environment. The best for environmental protection is still to stop the pollution. And bioenzyme, remember, bioenzyme contains or consists high concentration of COD, BOD, ammonia, and phosphorus. So its application for surface water, it cannot be overdosed. It has to be carefully done. Okay, and this signifies that continuous analysis of the water quality is very important. So during that time when I was doing this, it's like every 2 weeks I will collect the water sample and I will do the analysis. Okay,